Good day, IM2 student. Today we will start with our Module 2.3, Day 2, Solving Absolute Value Inequalities. Content Standard. Solve one variable equations and inequalities involving absolute value, graphing the solutions, and interpreting them in context. Language objective. Match absolute value equations and inequalities with their graphs, explaining and justifying reasoning. Okay, so solve the inequality algebraically, graph the solution on a number line. So first we need to isolate the absolute value by itself. So first step we need to divide by 3. So we have an absolute value of x minus 7 greater than or equal to 9 divided by 3 is 3. So greater than or equal to, we use the term or. So we said x minus 7 greater than or equal to 3 or x minus 7, switched in inequality negative 3, and then solve for x. So we plus 7 from both sides. So x greater than or equal to 10, or the same here, we add 7 to both sides, so then x less than or equal to 4. Right? So when we graph our number lines, we have 0. So let's say here is 10 greater than or equal to, so we need a solid dot point to the right. And 4, so let's say here's 4, less than or equal to solid dot point toward the left. Okay, notice that when we use or, the arrows are pointing in opposite direction. Right, let's go on to number 10. So we have the absolute value isolated by itself, so we can say 2x plus 3 is less than 5, and less than, we use the term n, so then you said n, 2x plus 3, switching inequality become greater than negative 5. So then n, we can combine them. So we said 2x plus 3 greater than negative 5 and less than 5. So then we can solve for x, so minus 3 from both sides. So then thus we do 2 is 0, so we have 2x greater than negative 5 and negative 3 give us a negative 8. And 5 minus 3, that gives us a 2. So then we're going to divide 2 from both sides. So we said x is greater than negative 4 and less than 1. So then from there we can do our graph. Right? So I'm going to do a rough sketch of the graph. So then this, say that this is a negative 4 greater than, so then will be an open dot toward this way, and this is 1. Less than, open dot toward this way. So notice that we use the word and, our graph is between these 2 points. Right? Okay. And so here, solving absolute value inequality algebraically. To solve an absolute value inequality algebraically, start by isolating the absolute value expression. When the absolute value expression is by itself on one side of the inequality, apply one of the following rules to finish solving the inequality for the variable. Solving absolute value inequality algebraically. If the absolute value of x greater than a, where a is a positive number, then we see that x is less than negative a, or x is greater than negative a. So then when we have this part, we use the term or. Number 2, if absolute value of x is less than a, where a is a positive number, then we say that x is greater than negative a and x is less than a. So when we isolate the absolute value, if it's less than a, then we use the term n. Okay, so let's start with our example 2a. So first we have the minus 15 from both sides. So we have 4 minus x is greater than 21 minus 15, that gives us a 6. So greater than, we use the term or. So we said 4 minus x is greater than 6, or 4 minus x less than negative 6. So solve for it, so we have negative x greater than minus 4 from both sides. So 6 minus 4 is 2, divide by negative. So we said x is less than negative 2, and then subtract 4 from both sides, so we have negative x is less than negative 8, divide by negative 1, so switch inequalities, x greater than 8. So then, my mistake, instead of 8, let me change that 6 and 4, that gives us a 10. Right? So then this gives us a positive 10. So then that's why we have an open dot here and an open dot here. Okay. So the same thing for B. So we need to isolate. We add 10 from both sides. So we have absolute value of x plus 4, absolute value less than or equal to negative 2 plus 10, that gives us an 8. So less than or equal to, we use the term n. So you can say x plus 4 is greater than or equal to negative 8, less than or equal to 8. And then subtract 4 from both sides. So x is greater than or equal to negative 12. And less than or equal to 8 minus 4 is 4. So then 12 is here, less than or equal to 2, so we need a solid dot. And 4 here, we need a solid dot, and I mean that is between those 2 points. Okay. And here is a word problem. So solving a real world problem with absolute value inequality. Absolute value inequality are often used to model real world situation involving a margin of error or tolerance. Tolerance is the allowable amount of variable in a quantity. Example 3. A machine at a lumber mill cuts boards that are 3.25 meters long. It is acceptable for the length to differ from this value by at most 0.02 meters. Write and solve an absolute value inequality to find the range of the acceptable length. So, identify the important information. The board being cut are 3.25 meter long. The length can be differ at most 0.25. So I want you guys to know that at most is less than or equal to. Right? So the length of the board be L, send the signs of the difference between L and 3.25 doesn't matter. Take the absolute value of the difference. So the absolute value of the difference can be at most 0.02. The inequality that models the situation is absolute value of L minus 3.25, closed absolute value is less than or equal to 0.02. And then solve for L. Okay. So the bounds of the range are positive and close to 3.25, so this is a reasonable answer. So then the correct answer is you take 3.23 plus 0.02 is give us 3.025 and 3.27 minus 0.02 give us 3.25. Right, so then this is our turn to do example 11. Said a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounces. Write and solve an absolute value inequality to find the range of acceptable weight. Okay, so then we know that x is the weight that is vary, right, minus the supposed weight, and it says as much as, so that means that less than or equal to 0.1. So then we see that then this is less than or equal to, we use the term n. So we said x minus 13.8 is greater than or equal to negative 0.1 and less than or equal to 0.1. So solve for x, we use plus 13.8 plus 13.8 plus 13.8. So that's reduced to 0. So x will equal to 13.8 minus 0.1, that gives us 13.7. Less than equal to, this is 13.9. So x is somewhere between 13.7 and 13.9. Okay, so let's try to solve this. So first we need to isolate the absolute value. So divide both sides by 3. So we have an absolute value of x minus 6. 9 divided by 3 is 3. So then this is an AND statement. So we write x minus 6 greater than or equal to -3, less than or equal to 3. So I'm going to add 6 to, oops, my mistake, not 9, but 6. So this reduces to a 0, so x greater than or equal to negative plus 6 is 3, equal to 3 plus 6 is 9. So then here, greater than or equal to, so we have a solid dot, and less than or equal to 9 is a solid dot, and it's between these two. Okay, number 7, so we need this same thing to isolate x, so we say that minus 17 from both sides. So absolute value of x is greater than or equal to 20 minus 7 is 3, so then we use the term or for greater than, so x greater than 3, or x is less than -3. Be careful that you need to switch the inequality. Right, so x is greater than 3, so open dot, point toward the right. Less than -3, so open dot, point to the left. So an or statement have an arrow pointing in 2 different directions. Right. Number 8, so to solve x, we need to isolate the absolute value, so times by the reciprocal 2 over 1, 2 over 1. So that's reduced to 1. So we have an absolute value of x plus 5 greater than or equal to 4. So greater than or equal to, we use the term or. So you would set x plus 5 greater than or equal to 4, or x plus 5 less than -4. So solve for it. So x greater than or equal to 4 minus 5 gives us a -1, and or minus 5, so x is less than or equal to -9. Right? So then greater than or equal to -1, so a solid dot point toward the right. Less than or equal to -9, solid dot point toward the left. Okay. So same here, we need to isolate the absolute value. So first step is to add 7 to both sides. So absolute value of x minus 6 greater than, so -3 plus 7 can give us a 4, greater than, so it's an or statement, so it says x minus 6 greater than 4, or x minus 6 less than -4. Right, solve for, so plus 6 times 6, x greater than 10, or plus 6, so x is less than -4 plus 6 is 2. So greater than 10, so open dot, point toward the right, and less than 2, open dot, point toward the left. Okay, so this is number 9, is a real world problem. The organizer of a drama club wanted to sell 350 tickets to their show. The actual sale were no more than 35 tickets from this goal. Write and solve an absolute value inequality to find the range of the number of tickets that could have been sold. So then x is the number of tickets minus 350, that's their goal. And they said that it could be no more than, so it could be less than or equal to 35. So we can set this to solve for x. So we say x minus 350 greater than or equal to -35, and less than or equal to 35. So I'm going to add 350 to all of this. Right, so that's reduced to 0, so x greater than or equal to, so then 0 minus 5 is 5, 4 minus 3 is 1, so that gives us 315, equal to 0, 8, and 385. So the range for x is between 315 and 385, including 315 and including 385. Right, number 10, the temperature at noon in Los Angeles on a sunny day was 88 degrees Fahrenheit. During the day, the temperature varied from this by as much as 7.5 Fahrenheit. Write and solve an inequality variable value inequality to find the range of possible temperature on that day. Right? So we say that x is the unknown temperature minus the actual temperature, which is 88, and as much as, that means that less than or equal to 7.5. So then we can set this x minus 88 greater than or equal to negative 7.5, less than or equal to 7.5. So we're going to add 88, so that's reduced to 0, x equal to, so I'm going to use my calculator for this, so 88 minus 7.5, so this gives us 80.5, and then 88 plus 7.5, so this gives us 95.5 degrees Fahrenheit. So make sure that you include the unit. Okay? So that's the end of our Module 2.3 Day 2. You have your bookwork, and make sure that you finish your HRW. Everyone have a good day.